Okay, so this is me. I'm Adam Chlipala, and I'm going to give a talk that might at first seem a little ill-typed for this meetup because it's not about Haskell. But before you all run out, I'll assure you that it's about a programming language that is statically typed and functional and has monadic I/O and type classes. That probably rules out most of the languages out there. So hopefully you'll find it interesting. So this is UrWeb, which is a domain-specific language for, as the web part of the name tells us, implementing modern web applications. And there's this other part of the name, so the web part is the web in this picture. This is the logo of the language. The part is this little lambda. It's a new general-purpose typed functional programming language. Put them together and you get a nice DSL. The model of the language design is that the compiler understands what you're doing when you're writing web applications. So it can use type checking and other good stuff to catch mistakes for you. The three main things I've been going for in designing the language are first programmer productivity and then also security and performance, especially in server-side code. And there's a modest amount of use of UrWeb in the wild today. Here's one example of an application called BazQuack's Reader, named by a non-native English speaker, as you might guess. It is an RSS feed reader. Here's the URL for it. It has thousands of people paying for subscriptions, and it looks like this, much nicer than anything I could design. And it's a constructive proof that UrWeb can be used to make things look like this. By the way, at any point, I'm really happy to take questions or musings, or we'll get to a demo of code eventually, and at that point it will be especially fun to suggest changes or bugs I can introduce intentionally, and we can see if the compiler catches them. So to repeat the sales pitch again for this language, why do you want to use this language instead of Haskell or PHP? The first version of those is probably harder to make an argument for in this audience. So the thing that makes UrWeb unique is that it has a very high-level programming model where instead of taking a general purpose language and building all these libraries that the compiler doesn't understand, the compiler will understand the big pieces of web applications, and I'll have examples soon. There's an exceptionally good security story, so some of the most common security bugs just can't happen, just like Haskell programs shouldn't be able to have seg faults or some other property like that. And there's also unusually good server-side performance of your applications. And I think most programmers out there are never going to want to use UrWeb, but if you like Haskell, I think there's a good chance you'll like UrWeb. It has all those fancy abstractions that Haskell programmers love and most programmers run away from. So probably most of you have good chances of wanting to run towards it instead of away. And then you might find that you can produce good web applications much more quickly than with other options. So what is this about the programming model? Basically, there are explicit static types capturing all the key pieces of a web application. So the compiler can analyze them and tell you when you made a mistake. And this is all based on a very general expressive type system, which is not specific to the web, but actually lets you encode things like the syntax and typing rules of HTML efficiently as a library. I don't have time to talk about the details of the underlying type system, but you can find information about this on the project website. What's the security story? Well, the most common security vulnerabilities are impossible by construction. This is actually pretty easy to do in Haskell frameworks also, just by using abstract syntax trees instead of strings. So, for instance, code injection attacks and cross-site request forgery attacks are provably impossible against anything that comes out of the compiler, unless you use the foreign function interface and those other backdoors that we are used to seeing in languages. Finally, the performance of the things that parts of your application that run on the server is very good. There's a domain-specific whole program optimizing compiler that tends to produce code which is more efficient than what you would have the patience to write in C. One caveat is that UrWeb has an unusual concurrency model, which I think makes programs much easier to reason about, but which does have some performance costs, and I'll say a little bit about that later. To highlight this performance part, this text is a little too small to see, so I guess that means you have to believe me when I tell you what it says. This is a screenshot of a third-party web framework benchmarking site. It's called Tech Empower Web Framework Benchmarks. There's the URL. This is the results for the one of their tests, which I think is the most realistic for classic web applications involving accessing an SQL database and generating HTML. UrWeb is coming in 4th place for throughput in this chart out of about 90 frameworks that are participating. All the popular ones are there. And it also has the best latency out of all the frameworks that are entered. And there's a new optimization in the compiler that should make this should move it up at least a little bit in the next round. So it does pretty well for performance despite the higher abstraction level. Yeah.
If I remember correctly, Snap and USAT are like somewhere at the bottom of the list.
Right, I was going to get to that. Where's Haskell?
Haskell?
Actually, Snap and USAT are not at the bottom of this list. They're not on this list. I don't know why no one bothered to implement this test for Haskell yet. So here's potential homework for anyone who's interested in a fun side project. A few of the other simpler tests do have Haskell implementations, but these 3 frameworks, whose names I will not try to pronounce for fear of embarrassment, they tend to have throughput that is worse than half of what UrWeb has, so there's a challenge for you. See, I don't know if there's some simple changes that an expert would apply that would make that better. Yeah.
One thing that I remember seeing, the last time that they had run it, I think, they were using a version of GHC that was like 2 or 3 versions old that didn't take advantage of a lot of the changes that they had made to the I/O system that they had presented about at ICFP last year.
Okay.
So there's a decent chance that as of when they had fixed it, the next time that they run it, which I don't think they've done it yet, the Haskell stuff will shoot up a decent bit.
Okay.
Yeah.
Look forward to
Plus, we have lighter weight frameworks than those too, so there's
Okay.
other stuff.
So,
Someone
I'm
has to
sorry,
add it.
while we're interrupting you, so how do you do whole program optimization? I mean, do you have to have like, how do you sort of do modular programming?
I don't know how to answer that question. You might know the Milton compiler for standard ML. Maybe not. It's roughly the same sort of thing. Modular type checking is the distinct thing from whole program analysis and compilation. I don't know if that koan answers your question.
Sorry, can you say that again? Maybe
You can do type checking separately and still do compilation as a full unit, and you have the modularity that you want.
Well, you want to be able to
Save.
You can have modules and like all of ML's higher order modules, but you need to compile everything at once. You can't like compile HR and just drop it in somewhere.
So that's one of my requirements to call something a module, is to be able to compile it and then not compile it again.
That's not that there are many reasonable people who disagree with that definition.
All right.
Was there another question? Yeah.
Have you got any converts from this Tech Empower thing?
I've gotten emails from people who are considering being converted. Maybe some have secretly converted already, but I haven't seen the evidence on the web yet. Right. Okay, so I want to start out getting into the meat of the explanation of UrWeb by reviewing the model that web programmers are used to today for building web applications. So there's the web server, which runs your code. You're in charge of that. And there's this army of browsers out there that you have no control over. One day, a browser sends your web server over HTTP, a URL describing a page that should be generated. The web server responds with some HTML. And web server might be talking to a database using SQL. The browser might use this AJAX style to make calls to the web server without reloading to a new page. It looks roughly the same as the traditional request, but it might use formats like XML or JSON to represent the requests and the responses. Then when the browser gets a response, it uses JavaScript to modify the page that's shown to the user, and this is done with an interface called the DOM, which I call the big old mutable global variable approach, where the page is a thing that anyone can change at any time, and commonly particular subtrees of the document are identified by looking their nodes up by string IDs. One last piece is sometimes the web server wants to send asynchronous messages to browsers. This works using buzzwords like Comet, and it looks a lot like some of the earlier stages using some of the same protocols. All right, so now let me bring all these protocols and languages onto the screen for an encore, and I've highlighted some of them in yellow here. Any guesses what is the commonality that someone might complain about that is related to what I've highlighted in yellow here in mainstream web programming?
They're all strings.
Right, they're all usually represented as strings, so your programming language doesn't know what you mean when you write things in these languages, and it can't help you avoid making mistakes. And you get things like code injection attacks, which are just silly when you think that all of these could be represented as abstract syntax trees, and the language would help you use them properly. So UrWeb does it the right way, and in particular, let's revisit that picture in the UrWeb world. So we still have the web server that you control and the browsers you don't control. Now, interaction starts when the browser calls the web server and says, here's a first-class function value. Please run this for me and show me the result as a page. The page comes back as a strongly typed document tree, and embedded within that tree in some nodes are further functions, which the browser might decide to later ask the server to run as well. So these functions are instead of URLs. And they're implemented as URLs, but the compiler does that for you. You also can have a database where the web server communicates with it by sending over conceptually strongly typed SQL syntax trees and receiving back lists of native UrWeb values. So there's no explicit marshalling involved here. And a key point of the semantics is that a single request to the web server appears to be executed atomically with nothing else running concurrently. And this is based on the classic database abstraction of transactions, which the SQL engine probably supports for you already. And it makes for a pretty easy to understand concurrent program as these things go. But it has some performance costs compared to a lot of non-transactional ways that web apps are being written today. That shows up in some of the tech and power benchmarks. Particularly, there's a write-heavy benchmark I didn't show where UrWeb really gets hammered by that. All right, so the browser might also make one of these AJAX-style requests, which is, again, just saying, here's a first-class function, please run it for me, send back the result. And the result might be a value of any type, not just an HTML page. And you don't have to parse it. It comes back in the normal typed format. And now the browser needs to use that result to mutate the document that's being shown to the user. The way this works is using a functional reactive style, where the program has allocated a set of mutable data cells, and the page that is displayed has to be described as a pure function over the values of these cells. So whenever the value of a cell changes, the runtime system figures out the consequences of that change for the displayed page. It automatically redraws just the parts of the page that were affected. And the browser can spawn any number of threads, and these threads are created within UrWeb code, and they themselves run UrWeb code. So all of this picture lets you code in a single programming language, which I will highlight by building a web application in a single Emacs buffer in a few minutes, in a single source file. And the threads are running simultaneously, but in a simple cooperative model, where one thread keeps running until it reaches a well-defined context switching point. For instance, a function to make a call to the server introduces the context switch, but otherwise you know that you're running and no one else is interrupting. And it's actually sound to consider that at any point in time, exactly one thread is running across all the clients that are using this web application. Because of the use of transactions in the server, we can reduce everything to that simple model, when actually there's a lot of concurrency going on to improve performance. But the programmer doesn't need to think about that. So the last piece is that we want to allow the web server to send asynchronous messages down to the clients. So the way that works is that there are typed message passing channels that can be stored in the database and also passed to clients. So imagine some earlier interaction created a channel. The right end of it is stashed in the database. The read end has somehow become part of the lexical environment of this client-side thread. And now the server is running some code which extracts the channel from the database. We just write some code that dumps the value in the right end, and it pops out the read end on the client, and it just looks like storing a value in a variable. There's no explicit network stuff or parsing or pretty printing needed to make this work. Right, so this is the picture story of UrWeb. I'll have some code very shortly, but are there any questions at this level before I go on? Yeah?
What happens if you ask the server to run a function that captures one of those mutable cells in this environment?
So that can't happen because the marshalling the compiler does for you and sending values from here to here is going to, you'll get a compile time error about not being able to send one of those over there, I think. Other questions? Here. Yeah.
Is it similar to what Gershon was describing when he had his talk where cells over here can update cells over here on a page?
No, these cells here are local to particular pages. The compiler will not let you reference another page's cell from
Sure,
one
but
page.
on the same page, like you can set it up so that you can, like changing a selector over here can update some things.
Yeah.
Here, but it's all sort of in lexical scope.
These are first-class objects. They're like ref cells in ML. I'm not sure if there's a Haskell counterpart. They don't. They don't need to all be declared statically at the top level of the program. You can create them dynamically.
Could you do like a pub sub? Some of them need to listen to a change of state. Number 1 changes, and 2 and 3 and 4 update something.
You can implement abstractions that have the ability to register a listener, but it's not something that's built in.
Okay. What's the protocol between the browser and the web server? Are we still in HTTP land?
Yeah, this all works in standard browsers and uses various. There's a native serialization format that is used for values and sending them over the network.
Now this is compiled down to JavaScript.
Client-side stuff is JavaScript. Server-side stuff is native code.
So assembly or C?
Goes via GCC or Clang, so C. One last teaser before I go to the demo. Some of you probably know that about web frameworks like Ruby on Rails that have functionality called scaffolding that will build part of your application for you. For instance, you say, here's my SQL table schema, produce that application for me, which lets me read and modify the contents of the database table. You do this in UrWeb too. In fact, that impressive screenshot is coming from UrWeb. And here's the code that instantiates a library component to build that output. Basically, we declare an SQL table and then pass it to a library module, and it does the rest. The interesting thing here is that this is the code we're calling here is statically type checked, and if it type checks, we're guaranteed that no matter which database table we call it on, it always outputs code which is reasonable in terms of freedom from code injection attacks, knowing the right database schema, and all these generic correctness properties. So there's a very expressive type system that makes it possible to do that kind of thing. Question?
Does that mean that the types that you're able to work with in the language all have to map pretty cleanly into a row in a SQL database?
No. The types you're allowed to use in positions like this need to belong to a type class of SQLable types. Definitely it's not a universal type class, like functions aren't in there. Yeah?
Now that we've seen some syntax, what's the relation to SML or something like that? Is it superset or just influenced?
Just influenced. All right. So I'm about ready for the demo. I want to add one more remark before I forget it, which is if anyone's interested in building some sort of commercial application using a cutting-edge functional programming language, please talk to me. Interested in supporting that kind of thing, and hopefully this demo will convince you that it might be a reasonably fun experience. So let me switch to Emacs now. Here. How do we feel about this font size? Is this good? All right. So here's my Hello World program. You can see it's a mix of standard ML syntax and Haskell code structure, and that this is an IO monad kind of context where we have to explicitly return this HTML literal, which is being parsed by the front end and desugared into calls to combinators that build syntax trees. I can ask Emacs to compile this code for me. It works. And let's load a very exciting page that we've come up with. Oh. Do I have the room? Oh yeah, I need to create a database first because I have this set up to expect a database. So actually, one more step, sorry. Let's create a database called demo because the web server expects there to be one. So now it should just start running. Okay. So here we have hello world. Advanced material. Yeah?
So sorry to already ask you a question for the hello world.
Go
But
for it.
so you mentioned that XML was sparse and de-sugar. If I wanted to write my own language like that, is that something to hack the compiler for, or can I do that in a library? Do you have templating of some sort?
You could do that in a library. The optimizer wouldn't be as effective at optimizing your library. I think that's
Page
basic.
source.
Hmm?
Page source.
Page source. I don't know.
HTML page
Can you
source.
view page sources, basically?
Yeah, view the page source. Okay. It should be pretty unremarkable. Yeah. So one thing the compiler does here is it knows that consecutive spaces are the same as single spaces in HTML, and it automatically removes consecutive spaces without having to make your source code unindented and ugly.
What about outputting something like HTML5?
There's a compiler flag to do that instead from the same source code. I'm not sure how I make this thing go away in Unity, so I'll let it stay there. Alright, so let's start doing something more interesting. Please feel free to interrupt at any time suggesting I type something different, and so we can see what happens. But let's create a database table. I'm going to do an example of a chat room service. And let's create a database table that stores the rooms that exist. Each one has an ID and a title. ID is an int, title is a string. And so we're basically declaring a database table as if it were a global variable with a sort of list of records type. So let's compile this. And now the compiler has created the database table for us. So if I connect, I'm using PostgreSQL here. So if I connect the database table, I should be able to create some rooms. Let's create rooms 1 and 2. Okay. And now we want to do something with this list here. So let's query the database. The standard library has all these higher order functions for working with SQL queries. Query X1 is one of those. It runs a query and then folds over the results, taking some XML for every row that comes out and concatenating all those pieces of XML together. So here's the higher order function argument that will be passed. We'll call this function on every row that comes out of the query. And let's, for every one of those, create not put a link yet. Let's just project out the title. This is the anti-quote syntax with these curlies and square brackets.
It's a stupid question.
Sure.
Sorry, but what happens if you get one of the terminators?
We can answer that question. Actually, let me finish putting in stuff that should work, and then we will break it in the way you've suggested and see what happens. I think it'll just be a parse error, and it might be a strange one, but we'll see. Okay, so that worked. Let's just, before I break it, let's check that it works at the moment. Here we go. All right, so let's forget a terminator with the speed example.
Yeah.
Okay. That's a very good error message. I'm impressed. Okay.
What kind of SQL is it outputting? Is it that SQL or
That
is it
SQL.
optimize that?
It's that SQL. A SQL with the same abstract syntax tree as this. The concrete syntax will be a little different. Yeah, it doesn't try to optimize the queries. It leaves that to the database engine. It's a very direct interface to a database engine.
So you've got something like do notation that you don't actually need to say do.
Right. It's just that syntax is available everywhere by default.
Okay.
I've never quite understood why do is required in Haskell. Maybe someone could explain to me, maybe offline. That would be best, but yeah. Question.
How does when you do title : string, what SQL type does that convert into? Is that like a varchar, and what's the length?
It's text in Postgres, which
It's
has no
text.
length.
Okay. What if you're doing? I mean, can you do like MySQL? Or,
Yeah, so you
SQLite.
just pass a different argument to the compiler in the command line, and you get MySQL or SQLite. In general, there's a plugin system that you can add another one to. Because they all have their different names for what I'm calling straight here.
Right.
All right. So we have a list of rooms. What should we do next? Let's actually prove that.
One more quick question about
Sure.
database typing.
Sure.
Can you introduce more specific database types, like a date time kind of thing to match with it, or those are
Date time is in here. Yeah, it's just called time.
So are the primitives of UrWeb based around SQL types roughly-ish?
I guess you could say that, but they tend to be the same primitive types you'd have in any functional programming language anyway. There's a built-in mapping. So let me pre-declare a little structure here. Chat function is what we're going to call to go into a particular chat room. We'll call this function with the ID of the chat room. So I can call this library function one row E1, which is for running a query that's return one row with one column. So just a single value. Let's select from the chat room table all the rows that have the ID we have asked for. And then we can return tags here.
So what, I'm sorry. So what does this do if it doesn't find a row or it finds multiple matches? Or
You'll get an error page.
all right.
It'll throw an exception. So this should do something useful. Let's call our function here. Instead of href, I'll write link, which is the syntax for giving an UrWeb expression instead of a URL. In this case, let's call chat on the ID field. And close that. Let's see how this goes. Okay. Oops. All right.
So could you show me your diagram you described sending a first-class function? Can you show
Right here.
what?
Oh, you want to know the implementation under the hood?
Yeah.
Okay. It's just, well, here you can see the URL. It's a serialization of the function call with arguments.
Okay, so what you send is not actually the function, it is a call of the function, which is already there.
Right. There's a set of functions that are available as a menu based on the structure of your source code.
Are those type checked in some sense before they're run? I mean, I feel like
Yes.
I don't know
In
anything
some sense.
about web programming, but I feel like there's an opportunity for code injection there where you
No,
differentiate
you don't have to worry
functions.
about that. It does the right thing.
So if you change them one to a string, like Bob or something like that in the URL,
All right. We can try Bob. I think
that's what
we'll
you're
probably
saying, so
get
like-
an exception. I think Bob is interpreted as the number 0 or something like that, and that doesn't exist as an ID in our table.
Can you add a second table and relate it as a foreign key easily enough?
Yes, that happens to be the next thing I was planning to type. So we'll see how that goes. Yeah.
Yeah. I might be getting ahead of you, but you made security claims about, I think, injection and client-side request forgery. What about information flow security guarantees, like bib integrity? Can the type system, for example, prevent me from accepting a cookie that I didn't hand out at some point?
The type system does not prevent information flow security bugs. There's a separate analysis, which is much more researchy than the rest of it, that does things like that. All right, so let's create that other table. This is going to be the table of all the messages that have been sent to all the rooms. So let's call it message. Put a space in there too. And so for a room where at a time someone said this. And I think I can put goes. Yeah. I forget, actually. Because you said foreign key, I felt inspired to type it here, but now I forget exactly the domains in there and they get type checked. So with this compilation, this table just got added to the database. We haven't, in this case, asked the database to enforce that this points to this. In practice, that's how we'll use it. So now we can.
I'm sorry again. Is select a first? I don't understand. Is select a sort of first class member of your language?
This syntax is desugared to by the parser to calls to combinators to build queries.
Okay. So in theory, you could write down the combinators. It would be ugly, but
yeah,
first class.
That's right. So let's actually read the list of messages in this chat room. So let's get all the text of all the messages that have the right room. And while we're at it, let's put them in chronological order. And then, so this is a higher order function that we call this function on every row, and let's just pull the text out of the row and put a new line, and there we go. So now I can just dump that log in here. Let's put it after a horizontal line. Good. And to actually make anything show up there, we can manually put it in the database, but more interesting will be to put a form in here. The user can type a message and have it be sent. So let's put a text box here. All input widgets have names here that are processed by the compiler and used to form a record that contains the values of all the widgets when we finally submit the form. And what we're writing here is when the user clicks this button, call a function called say, which isn't actually written yet. But we can put it in here. So it takes in a record, which will have just one element in this case because there's just one widget. We can insert into message. Exactly the values you'd expect. So the ID and the current time using an SQL function and the text. And afterwards, we can just recursively call the same chat function that we were inside to begin with and show what would have been shown there anyway. All right, so that's the end of version 1 of this demo. I'm going to start making it fancier next. Any questions about this version before I go on?
I have a question.
Yeah.
How involved does the compiler get in checking that the output HTML is going to be valid?
It's completely involved in the sense that if you manage to get invalid HTML, send me a bug report. The compiler is not supposed to allow that.
So your first example, output a list, or output a bunch of list items, but not wrapped in an OL or a UL.
What I mean is the definition of validity that I have in my brain from 1995. Or at least, you want to avoid problems that will create security issues at least, and other things are bonus. Yeah.
So what all got sent when you ran this say callback function?
It sent a post with the value of this text box.
And how does it know which chat room you're in? How's it keeping track of that?
All right. It also included the ID and the URL of the page that was getting posted to. All the captured variables from lexical scope are automatically appended to URLs as necessary.
Appended how? Is it's post parameters or?
They're literally there in the URL. They're not post parameters. Okay. So question, yeah. Well, there are no DOM updates here. This is still a 20th century style application. But we'll get to the DOM updates soon, or we'll run out of time first. Yeah.
Do you have any protections against potentially malicious user mucking with the URL?
the model that the programmer is supposed to have in mind is that all the functions that are callable by URL should be safe to call for any well-typed arguments. You don't have to worry about arguments being ill-typed, but they could be anything. And you just have to think about that. They could be any well-typed values. Yeah?
What would happen if I inlined mistakenly the body of say into the curly braces where?
So if I just wrote it as a lambda in place of,
Yeah.
then the compiler would complain that you've used an action that is not a named function, so it doesn't know a good URL scheme for you. Right, so in general, named functions are the way the programmer suggests nice-looking URL schemes to the compiler. It's a requirement. Every callable function is named somewhere. All right, so the next change I want to do is a pretty small one. It starts to show the options for modularity in a language that has first-class treatment of web application pieces. So I'm going to put all this stuff about chat rooms in a module that exposes two methods. One, so here's where we see transaction, which is basically the IO monad equivalent of UrWeb, but implying that everything can be undone after it's been done. So we can create a transaction that lists all the rooms. It is like an IO computation that returns a list of records. And we can also expose our chat room as a thingamabob that takes an ID and returns a page, which is what we've implicitly been constructing all along in a function like chat. So let me do the all-important indentation to seal the deal here. Then we have a genuine module, and I should add this rooms method, which is pretty simple. It's basically just wrapping an SQL query to select all of the rooms, but let's also order by title like we did somewhere else. Okay, so that's step one. And then let's actually use this module. So now this main code doesn't even need to know which database tables there are. It just uses an API. And so I can replace that code by calling the rooms method. Let's take this higher order function parameter and put it in here and call, let's say, the list map to produce XML function. And works with the same argument. And now rooms is a list instead of a database table. Hopefully this works. And nope, we need to qualify this to say now chat comes from the room module. Right, and take my word for it, it's exactly the same behavior, it's even the same code that's generated, but it's nicely encapsulated, so these database tables are now private state of the module. No other code can access them directly. So they're like the hash table, like the array inside your hash table in Java. You can enforce whatever invariants you want on them. For instance, we could say, actually, I told you it was an int, but it isn't. It's a special new type of identifiers, and now client code can only get identifiers by listing rooms, and the only thing it can do with them is pass them off to the chat function. So with that small change, code still works, and if I try to do something suspicious like take an ID and add 1 to it, I will be scolded and told, that's an int, but you needed a room.id. So you can, just by making database tables first class, you can take the usual encapsulation features we love from high-level programming languages, and they just work in a nice way.
That message suggested it might have been willing to let me add a room ID to a room ID.
We'd get a different message if we tried to do that. I think this is going to be a no type class instance for room ID. Yeah.
Since the room ID is serialized, can you subvert this modularity by going round-tripping through serialization?
No.
Well, the client can type in a number or whatever, but it's just going to do
Right,
whatever
so
the language.
the client can ask for crazy room IDs in calling the chat function. I think that's the only opportunity for that in this program.
So this is the defense. This is a tool to keep the program from writing defense, but not a security.
Yeah.
Mm-hmm.
So all the serialization stuff is inside the compiler, and you can't access it.
Right. Question? No. Okay. So looking at the time, I'm wondering what I should be thinking about in terms of when I should wrap up.
Are folks happy to keep going? I think let's just keep going and
Okay.
wrap when you want to wrap.
Probably about, I'd naturally go for about another 20 minutes, I think.
So is that a paper you're reading from? A paper that you wrote, or?
It is.
Oh.
It's not online at the moment, but there is all sorts of documentation online that is a potential substitute. I just have basically a printout of the source code right here.
Quick question about what you're presenting. Are you
Sure.
using some of those channels, the asynchronous channels?
Yes.
Awesome.
Or I'll run out of time. One or the other. So first, I just wanted to introduce more basic client-side programming. So let me rewrite this to work in a little bit of a different way. Instead of getting the log, I'll run almost the same query, but I'll say query L1 to just return the list of results. Instead of building XML out of it, we'll build the XML later. And let's actually get the timestamp from every message that we're selecting.
What's the one?
One table. If it were multiple tables, we'd have a nested record of records. With just one table, we only need one level of records. And actually, before I do this, I'm going to copy in a useful GUI widget that I have here. I'm doing everything in one file in this case, which is not at all required by the language. Just makes it convenient for a demo, but like in OCaml, every separate source file is interpreted as a separate module, and it can have a signature like this one here to constrain access. So what I've just dropped in is a log GUI widget that has an abstract type of logs. We have operation to create one. When we have one, we can append a string to the end of it. This transaction in both cases indicates this is an effectful operation. And we have a pure operation that takes a log and converts it into a piece of HTML that fits inside a body tag. And I don't want to dwell on the details of it too much, but I'll just point out a log is like a list, except in the tail position of a con cell. Instead of just having another log, we have a source log. This is the type family of data sources, which are mutable cells. So this indicates once an element is added to the log, the contents of that element, the actual string that someone sent, is fixed, but we might later add new things at this position. We might grow the log at any point. And the type of logs is actually includes a head and a tail. Let's just pretend it's only the head, and the head is a data source that holds the current log. And we can render logs by we have this HTML pseudo tag called DYN for dynamic, which basically lets you put an UrWeb expression in this position, and it says evaluate this expression to some HTML and show that. But if any of the dependencies of that expression change, the runtime system should automatically reevaluate it and put the new result of the evaluation in the same position on the page. This is expressed using a monad, like in other, at least some other functional reactive programming approaches. We pull out the head of our log, which is a source. We use signal to coerce it into a time-varying expression, and then return the result of rendering that value with another function, which just does a pattern matching and sort of recursively does the same thing afterward. So the important thing is, whenever the underlying data in this value changes, the runtime system will automatically figure out how much of the execution of these nested recursive calls needs to be redone to produce something new to show on this part of the page. That was kind of quick, I know. There's a simpler demo of this stuff online. That could be helpful to pick up some of the details after I'm done. But for now, I want to return down here where we've selected a list of all the texts and timestamps of all the messages in the table. And what we can do with that is let's create a new log with the method of that module. And let's also calculate what was the timestamp of the last message we've seen, which will be helpful to do using a helper function for folding over one of these lists and getting the maximum timestamp. So for every element, let's take the max of its timestamp with the accumulator and start at the minimum time. So the last seen time is the data source holding the max timestamp computed from the initial contents. now in place of rendering the log, we can call the render method, which takes our widget data structure and turns it into HTML. And now, let's take this body and add an onload attribute, which is this is going to be a piece of UrWeb code to run on the client as soon as the page is loaded. What we do is we iterate over all elements of the initial list, and let's append every one of those to the log. All right, so this should be enough to show us the messages that we already added in an earlier phase of the demo. Let's see if that is true. Okay, so take my word for it. This same content was rendered in a very different way than last time using client-side code. And we'll see that in action a little bit later. So let's actually create a way to add new messages. So we still have this save function here, but instead of making it a form handler in the 20th century style, let's make it a fancier one that'll be called an AJAX style call. We'll just pass it the text instead of a record. We don't have to bother with records anymore. Why that's true should become clear soon. And instead of returning a page, let's return the result of a query row, much like this one. So I'll just copy this. The idea is, every time the user sends a message, the server recomputes the list of new messages that have come in since the last message that the same client saw, and returns that as part of the same RPC that requested adding a new message. So to make that work, the change I have to make is filter only those messages that are greater than the last seen time. Kill that semicolon. And then finally, I'll change this to not be that kind of form. I'm going to create a data source for the message that the user wants to send, and we can write the C text box tag. C stands for client, and we just connect this text box to a data source. So whenever the user types something, the data source is mutated atomically. And we can have this button that is going to have a onClick attribute, which is a function that's passed which button was pressed, but we don't need to know which button for this example. So things we can do is get the current value of the text box, and then replace the text contents with empty string, and then get the current value of last seen. Then we're finally ready to make a remote procedure call, which is what RPC means. So we just give the name of a function that should be called from client code, but make it run on the server side. And like I said, this happens atomically, so we don't have to worry about funny concurrency stuff happening, or at least certain kinds of funny concurrency things cannot happen. All right, so now we can set last seen equal to the maximum timestamp among those messages that were returned by this RPC. And finally, let's loop over every one of these messages. Every one of them should be new, so we should add it to the log.
You need all those semicolons?
I do.
See, the reason I became a Haskell programmer.
That's why you need the do, by the way, is to kill the semicolons.
I see. Okay, that's good to know. Right, so this might do the right thing now. Oops, still have a form tag in there.
Oh, yeah.
So if the message set is empty, then
that means it shouldn't be empty. It should be impossible because your new message happens after the most recent message you saw before. All right, so now we should get a little more exciting here and go multi-user and send messages to each other. Of course, it didn't appear right away here. Anyone who's managed to follow the control flow, this is probably isn't surprising that we don't get instant updating in other windows. But once we do send a message, we pick up everything that happened since our last send.
That's harder now?
yeah.
All right. I should probably change. I'll do it in this query. Just don't ask why I have to do this. Switch the order. Or actually, no, the other one is switch the order. Turns out query L1 to be efficient, given the way lists work, wants the results in the reverse order, so it cons it in the proper order. Now we should get the right order. Exactly the wrong order.
That's your most recent up on top.
All right, let's not worry about the details right now. It doesn't show up here until we type something else.
Yeah, now it's backwards. It's all over the place. Because you went most recent on the
From the pen.
top. Yeah.
Okay, so this is the Ajax version. The last thing I wanted to do was show a version that uses message passing channels, which is actually fairly quick, but let me know if I should make this the stopping point.
No, you go.
Keep going.
All right, so the next one's actually simpler. I think we don't have to do as much work when we have message passing channels. Let's keep that log there. We don't have to change that to make this work nicely. So, last step. All right, so what's going to happen now is whenever a new message is sent, the server has a channel to every client. It's going to just broadcast that message. We don't have to do this funny stuff with time stamps and bookkeeping. So the first thing we're going to do is add a new table. And because the tables are private state within this module, if we imagine a larger application that uses chat rooms, it wouldn't need to know we added this new table. It's a privately encapsulated state. Say it's a table that connects a room with a channel that wants to be informed of every new message that is sent to that channel. So channel is a type family of message passing channels. And now let's change this a little bit. We don't need this last seen distraction anymore. We can instead, let's use yet another higher order function from the library that iterates calling an imperative operation on every result of a query. So let's find all the channels from subscriber where they belong to the room that we're in right now. For every one of those, please extract the channel and send it the text that was just sent. We don't need this next timestamp anymore. So now, when we first enter a chat room, the first thing to do is create a new channel that the server will use to send us updates. So we just call this channel operation. And then let's dump it into the database. Chat room ID, channels, so this is all getting serialized magically, it's great. And same initial query is good. We still want the log. We still want the text box. We don't need this last seen stuff anymore. So the first thing we should do is take this onload code, make it a little more complicated. Still need that curly brace.
Really, the designers of the Ubuntu were Emacs programmers.
Yes. All right. So we'll initialize the log when we start, but let's also define a function that just waits for messages and adds them to the log. So how this can work is a recursive function that receives from the channel. So receive is a client-side operation, send is a server-side operation. They both have handles to the same object. Whenever we receive a line of text, add it to the log, and then loop around again, and let's spawn a new thread running the listener. So now whenever the page starts, we have a new thread running in the background whose only purpose in life is to receive new updates from this channel and add them to the log. And we're almost done. We just need to change the code in this onClick method to still get the text, still zero it out. Now all we need to do is just run the RPC that says the text, and it'll do it. So now hopefully, if I reload each of these pages, they will just be updating in real time. All right.
Cool.
I won't press my luck. Try to do something more fancier than that. All right, I think that's the end of the demo I want to do. Any questions?
So when you say DML, I'm sorry.
Whoever.
But when you say DML, does it make a round trip to the server?
This code that says DML is actually running on the server in the first place because it's accessed via this RPC syntax.
Okay.
It wouldn't be legal to run that on the client, which doesn't have access to the database. It doesn't automatically create an extra round trip.
Because I'm persistently curious with how you're making serialization work. Can I get somebody else's handle into one of those channels and pretend to be them on the client side?
No, because every channel has an associated client, and the server will just never send someone else's messages to you.
So it's keeping a consistent connection.
And in fact, when a web browser goes away, when it fails to respond to pings, the server decides this client is done, and it garbage collects all the database rows that mention the channels of that client.
That was my follow-up question.
Okay.
Nice.
So it keeps the connection alive.
The language implementation takes responsibility for keeping this connection alive as long as it thinks the client is still there. More questions?
What kind of, is that tunable, or like the policy for how long alive means and all of that, or?
Yes, it's
Or is it?
it's an option in the configuration file for your project.
Okay.
How long to wait between heartbeats. And that kind of
Okay.
Is that garbage collection visible in your single threadedness?
It should look like garbage collection happens atomically. A client goes away, and atomically everything that has to do with that client disappears.
So if you send to a channel that has, or is in the process of being garbage collected,
Right. That you shouldn't be able to see that behavior. The runtime system should prevent it.
How is that implemented? Is that requiring some kind of cascading delete in the database schema? Or,
No, the compiler automatically generates C code that knows how to delete everything related to a particular client, and it runs inside one SQL transaction.
What's the purpose of the log? I mean, what would you use that for?
You mean besides what it's used for here?
Yeah. Or is this what you sort of mean to use it for?
Well, I chose it to be a really simple, yet encapsulated in a quasi-interesting way widget. It's a place on the screen where you write new lines of text and you don't want to re-render the whole list of lines every time you add a new one. I think we can imagine using that for logging in a variety of different applications.
Yeah.
Or at least I can. Yeah.
So you say on the website that it's in this language is in the style of Haskell and all, but a significantly richer type system. Can you say some ways in which it's more?
I can give a very short description, which will either answer everything or nothing, depending on your background. It's an extension of F omega with type level records.
Oh, so it's a dependent.
It's not dependent types, but it's inspired by languages that have dependent types. It's really about type level computation instead of true dependency. So you can have functional programs at the type level that compute with records that stand for, say, database schemas, then compute new derived schemas, and use that translation to express the type of a function that does something related to databases.
We have full type abstraction. Types can be passed as arguments.
Well, types can be passed as arguments in Haskell too. They're just implicit. The language of types is more expressive and has more kinds of functional computation in R.
Sorry, this is kind of a follow-up
Okay.
to that question. What does the type safety theorem say about web browsers and servers and so on? Or does it say anything at all?
Well, you shouldn't be able to get crashes in the usual sense, but the type safety theorem is supposed to.
Do the operational semantics talk about kind of running code in different places, or is it just a
The operational semantics talks about running code in different places in the sense that it has the idea of there's a set of clients, each one has a set of threads, and at every step we pick one thread to run. And yeah, we should be able to think in terms of these high-level typed objects like tables and HTML and links, and the language implementation should make it look like that's what's really happening in the world, even though we know it isn't. Yeah.
Is it total?
It isn't. You can write non-terminating programs. There's a somewhat bit-rotted termination analysis in the compiler, which is turned off at the moment.
But I mean, you have two levels, right? You have the type level computation.
The type level is total. The value level is non-total.
But you don't. I mean, you don't. How to say this? When you compile, you don't need to run the value level computations.
It's true.
Okay. So it's not that bad.
It's pretty normal, I think. Yeah. Yeah.
Do you have some sort of trapdoor like FFI for talking to third-party JavaScript, for instance?
Yeah, there's FFI support for both C and JavaScript. And the nice-looking website I showed you before uses the JavaScript part, for sure.
So does this just compile directly to C?
C and JavaScript, yeah. Yes. That's sort of in the runtime system, and it's gross, like it has to be to work with browsers. Do you really want me to say anything more about it? It does the right thing. Minimal for some reasonable definition, which is moderately easy to implement. It's not perfectly optimal in the sense of you'd need program analysis to understand.
My garbage collection. What's considered to be associated with the user session? If I have a user's chat handle associated with the channel, and then
it's only channels. The garbage collector only understands channels. So you have to make sure everything that should go away is mentioning a channel that belongs to that user. And actually, there's another type for user handles which you could use instead if you don't want to create a channel.
What about indirect mentions though? So if I have a username mentioning a channel and then some messages mentioning a username.
You can use delete cascade in SQL to make that work.
But what if I don't want it to work? How do I keep all the user's messages from disappearing when the user disconnects?
Then don't put the. You can put the channel inside a maybe type, and then it just turns to nothing instead of deleting the row.
What about scaling and deployment? You know, if we go in production, are we putting this behind like an Nginx proxy? How do we go? You know, elastic load balancers. How does all that?
I can't think of anything that would go wrong, but no one's tried it yet, so I'm sure something would go wrong. But I'd be very interested in seeing what happens. I showed you those benchmarks, which are running loads which are way beyond what almost any website will ever see. That UrWeb application was doing hundreds of thousands of requests per second, which is probably good enough for almost anything.
And the name Ur?
It's based on the idea of an language in linguistics, which is the one that all the other languages are descended from. Because you can embed DSLs inside of it like SQL and HTML.
Are there projects for embedding other kinds of domains in Ur?
Right now, the compiler is very specialized to the web version of this, but I hope we build something more parameterized in the next few years. Yeah. So either I haven't talked to them or I don't know how to pronounce the name of their thing. But thanks for the pointer.
Yeah, we should continue this at the pub.
Okay, thanks everyone.
Right. Thank you.